So today I'm going to be talking about smart contract-based access control for the Internet of Things, based on the paper by the same name. And I'm first going to introduce the issue and then explain briefly about access control and the proposed framework which this paper had for solving this. And then I'll talk a little about the system before going into detail on how this access control framework works. And then I will present a little case study before reaching the conclusion. So first to the issue. These days, the Internet of Things, or IoT for short, is one of the most fundamental architecture for various promising applications, such as smart healthcare, intelligent transportation, or home automation, etc. But as I also explained in my previous presentation, which was about IoT security issues, the IoT system these days have crucial security issues, and adversaries can very easily intrude into a system and gain illegal access to provided resources like data, services, storage units, and computing devices. And they can easily and simply do this by deploying their own or compromising existing IoT devices. So access control has the aim to prevent illegal resource access from unauthorized entities, and it's becoming more vital research today. So before we head into access control, I would like to define two terms. Subject means that an entity can access resources, an entity that can access resources, and an entity that holds the resources. So usually the subject wants to access any resources from an object. So traditional IoT access control schemes are often built upon top well-known access control models, such as the role-based access control, the attribute-based access control, or the capability-based access control. I'm not going to go too into depth about how this works, but what these schemes have in common is that validating the access rights are usually conducted by a centralized entity, which then turns out to be a single point of failure. And to combat this, distributed CAPAC, aka the capability-based access control models, have been proposed, where the access right validation is done by requested IoT objects themselves. But the problem here is that the IoT objects, they usually come with low capability, and so they may be easily compromised by adversaries. And that's why IoT objects cannot be fully trusted as access right validation entities or agents. So the big question then is, how can we achieve distributed and trustworthy access control in the IoT? And so this paper, it proposes a smart contract-based access control framework, which is based on multiple access control contracts, one judge contract and one register contract. The multiple access control contracts, each of them provide one access control method for a subject-object pair, and it allows static access right validation based on predefined access control policies, as well as dynamic access right validation by checking the behavior of one subject. And it also provides several functions for access control policies like updating, deleting, and modifying. The judge contract provides a misbehavior judging method. When it receives a misbehavior report from an ACC contract, or from the access control contract, it judges this misbehavior and in return provides a corresponding penalty. And the register contract, it registers the information of the methods for management, it's like the name, subject, object, and smart contract, which are involved, and also provides functions for registering a new method or updating and deleting an existing method. So the system architecture, which is considered in this paper, consists of several servers, storage devices, IoT gateways, and user devices, which are all connected to a peer-to-peer network. And we can also see there's numerous IoT devices like sensors and actuators, which are connected via the IoT gateways. And in typical IoT applications, each pair may have some resources, like services, data, and storage space, that are needed by other pairs. And thus, access control must be implemented by all resource owners to prevent unauthorized access or use of the resources. For example, a server must be able to block the access request from users who have not signed up, or the access or request from the sign-up user who have not subscribed to some services. And so to prevent this illegal use of resources and storage, both storage and IoT devices must be able to restrict the access request from these unauthorized peers. And in this paper, they adopt the security model of access control matrix, and they do so by implementing the access control matrix by adopting the mechanism of an access control list. I'm not going to explain how this access control matrix works, but we will see the use of access control list later in the presentation. So now to the system configuration. The framework is based on the Ethereum smart contract platform using blockchain and smart contracts. And the basic configurations that are needed to apply the Ethereum platform is that each pair must be associated with an Ethereum contract account, through which each pair can claim the deployment of the smart contract and identify itself during the access control. And the Ethereum client can be run on all peers in the system except for the IoT devices, and this is again due to its limited energy and computing power. All clients are assumed synchronized on the same block, and by using the client, each pair except for IoT devices can directly interact with the blockchain to deploy smart contracts and send transactions to run the APIs, which are the functions of the smart contract. And these pairs can also function as miners to conduct a mining task for the system. And since the IoT devices, they don't have any Ethereum clients themselves, they have to use IoT gateways that act as an agent for their local IoT device by storing their accounts. And using these accounts, the IoT gateways, they deploy and execute smart contracts on behalf of its local IoT devices. And we assume that these gateways are physically accessible and thus unlikely to be compromised, so in order for them to be trusted as agents. And now over to the proposed framework in the smart contract system. We can see here in the picture there are multiple ACCs which implement access control for a pair of pairs. We have one judge contract which receives the misbehavior report of a peer from an ACC, and it judges the misbehavior and gives the penalty decision back. And we have one register contract which stores the information of both the judge contract and the access control contract, and it also provides functions to these contracts. So we'll look up into all of these contracts a little more now. So first on to the access control contract. An ACC or access control contract is deployed by a peer, which is usually the object, who wants to control the access request from another pair, which is the subject. A subject-object pair can agree on multiple access control methods. So one subject-object pair can be associated with multiple access control contracts, but an access control contract can only be associated with one and only one subject-object pair. And we can see here that also the access control contract, it contains a policy list and a misbehavior list. And we see here in the policy list, it shows the resource and the action, and it shows the permission for this action on the resource, and TOLR, which stands for time of last request. And so we here in the permission field can be used as a static validation, as a static access validation, while the TOLR can be used for dynamic validation, such as by detecting misbehavior and that the subject, for example, sends access requests too frequently in a short period of time. And to record these misbehaviors, each of these resources needs to have a misbehavior list, which we can see here, which is the description of the misbehavior and what time it happened and the penalty. And then we have the judge contract. The judge contract implements a misbehavior judging method, which judges the misbehavior of the subject and determines the corresponding penalty when receiving a potential misbehavior report from a access control contract. And the penalty can also be based on the misbehavior history of the subject. So the judge contract may need to keep a record of the misbehavior history of all subjects. And after determining the penalty, it returns this decision back to the access control contract. And you can see here that for each subject, it has a misbehavior record. And the register contract, the main role of the register contract in the system is to simply manage the access control and misbehavior judging methods. And to achieve this, it contains a lookup table which registers the information to find and execute all the methods. So you can see here, it shows the method name, which subject and object is about, the smart contract name and the smart contract address, and the creator, and which ABI it is about. So with the help of all of these contracts, the framework can provide many functions to facilitate the access control of an IoT systems. These functions mainly include registering, updating, and deleting access control methods, misbehavior judging methods, and as well as policies for access. And I'm not going to explain all of these functions, but I'm going to explain more the access control and how it works more in detail. So in step 1, we can see that so there's two pictures here. Well, A is when the access control is being called upon by a subject, and B is when it's being called by an object. And I'm going to explain the case of A. And so we see step 1, the server calls the get contract ABI function of the register contract to retrieve the ACC for the access control. And we see here. And step 2 is that the RC, the register contract, returns the address and ABI of the ACC to the server. The server then sends the transaction which contains the required information here for access control to call the access control function of the ACC. And we see in step 4, during the access control process, the ACC will send a misbehavior judge ABI to the JC. And if some potential misbehavior, and only if, the subject is detected. So this only happens if there is. And then step 5, once the misbehavior judge ABI completes judging the misbehavior and determines a penalty, it will return it to the ACC. And finally, the access request will be returned to both the subject and object after the access control process finishes. And so the main difference between the access control in figure B and A is that you see that it's the access request of the subject is forwarded by the object rather than being directly sent to the access control ABI of the ACC. And we can see here everything goes through the local gateway for the IoT. And in this paper, a case study was also conducted, which I will explain just briefly, where they used this one desktop computer, one laptop, and 2 single board computers, which was Raspberry Pis. And you can see the specs down here. They also used Get, Remix IDE, and Web3.js for the software to implement the blockchain and smart contracts. And they defined a very simple misbehavior, which was just sending requests too frequently. And they set the penalty to be locked out during a certain amount of time, which also was according to a recurrence rate. And the main purpose of the case study was to demonstrate the possibility of the framework to achieve the distributed access control for IoT systems. So of course this case study is in a very simple scenario, but and does not necessarily reflect the overhead of the framework in real-world IoT system. It just shows the possibility of it. And so here we can see like the results of the experiments. So we see in A is after the first picture is after 1 misbehavior, and we can see the penalties for 1 minute. And A here is the object and B is the subject. In the second picture is after 3 misconducts, and so in B we can see that you're blocked for the requests are blocked for 2 minutes. And in the last picture, it's after exhibiting 6 misbehaviors, and so it results in 4 minutes of penalty time. So in this presentation, I talked about the access control issue in the IoT and explained the proposed smart contract-based framework to implement distributed and trustworthy access control. I explained how the framework includes several smart contracts and how each of them work, like the multiple access control contracts for access control of multiple subject object person system, the one judge contract, which judges the misbehavior of the subjects during the access control, and the one register contract for managing the other 2 contracts. And I also briefly explained the case study which was done to show the feasibility of implementing the proposed framework. There's the references. Thank you.